Hello, my little mathematicians. Today we're going to review equations and inequalities. Okay, so first off, when you're solving equations, you use inverse, or sometimes referred to as the opposite operations. So in other words, if there's x like plus 2, then to solve for it, you do the inverse step. Plus 2, the inverse would be minus 2. If it was like, for instance, 6 times x, what's the inverse of times? Dividing. So you divide both sides by 6. Okay? And we do that in order to solve the equation and get x by itself. So to undo addition, you'd use subtraction, and to undo subtraction, you do addition. To undo multiplication, you'd use division, and to undo division, you'd use multiplication. You do that to isolate the variable, and then always make sure that you plug it back in to check. Okay, so again, we already kind of established this is being 6 times x, right? They're being multiplied. So the inverse of multiplying is to divide by that 6. That's how I'm going to isolate the x, because anything divided by itself is 1. And so now you have 1 times x, or just x. I can do whatever I want to one side of the equation as long as I do it to the other side. Because think of it as kind of like a balance. And so you can add, if it starts off already equal, that's what an equal sign is. I can add something to any side as long as I do it to the other side too, and then the equation will go back and balance. So go ahead, and since we divided this side by 6, then divide this side by 6. And 36 divided by 6 is 6. And then to check it, here's your original, 6x equals 36. You substitute in what you think the answer is. We think the answer is 6, so I'm going to replace the x with a 6, and then check to see if it makes a true statement. Well, 6 times 6 is 36. Bring down your equals and your 36. It's a true statement, so yes, that 6 is the correct answer. The other thing that we did in this unit is not just equations, but inequalities, okay? When we do inequalities, we want to graph the inequality statement on a number line to represent possible solutions. Because unlike an equation just has one possible answer, like x is 6, that's it. I wouldn't say x is 6, and 7, because 6 times 7 is 36. No, it's not. It's just one answer. But for an inequality, there's more than one answer. And so the arrow is either going in one direction or the other, and then your dot is, if it's a greater than or equal to or less than or equal to, then you shade in the circle. And if it's a greater than or less than sign, then it's an open circle, because this is not including that point versus these are included that point, because it's greater than or equal to, less than or equal to. So it's including that point if it's shaded in, not including that point if it's open. Okay. When you go to solve an inequality, to check your work, choose a value that's within the constraints. And constraints is just a fancy word for like within that range or within those boundaries. And then if it's correct, you should get a true statement, just like before. So let's see. Okay. Treat this like this were an equal sign. So what would you do to get x by itself? Well, what's the inverse of multiplying by 2? Dividing by 2. And whatever you do to one side, do to the other. 2 divided by 2 is 1. So 1 times x is just x. Woohoo, we isolated the variable. And then bring down here, 10 divided by 2 is 10. Bring down that inequality sign. And you're saying x is greater than 10. So any value that's bigger than 10 would work. So if you were to graph this, it would be an open circle, because it's not including 10, and it would be going to the right. Treat this as kind of like the arrowhead. See how this matches the arrowhead, so it's going to the right. You can use that trick whenever your variable's on the left. This serves as the arrow, that the direction it's pointing. Okay, and then to check it, your original is 2x is greater than 20. So according to this, you can choose any number greater than 10, and it'll make a true statement. So let's choose 11. 2 times 11 is greater than 20. Well, what's 2 times 11? 22 greater than, bring down the 20. Is 22 greater than 20? Yes, it is. That's a true statement. So since it made a true statement for me to plug in a number that's greater than 10, I know that that is the right answer to this inequality. Okay. Now, sometimes they like to give you a word problem or word phrase, and then you have to figure out what inequality is being used or which one to write in your sign as your sign for your equation or inequality. So right here, remember that we said an inequality is kind of like an equation. So if you see the word is less than or is greater than, then it's an inequality sign. So is less than, fewer than, smaller than, below, it's a less than sign. Same exact things, but if it says is less than or equal to, then it's a less than with a line underneath because it's including that point. So these go in the same direction, but this is an open circle and this is a closed circle if it's a or equal to. Ones that are tricky is if it's like the maximum. You see the word maximum, you would think greater than, right? But actually, okay, so if you think about this is like the maximum value I want it to be, but I'd prefer it to be lower. So it's actually a less than or equal to. Same thing if you see the word at or no, it's the opposite way you think. Because you see at most, you would think that would be a greater than or equal to. But for instance, you can be at most 2 years old to get into Disneyland for free, right? So can a 16-year-old over here get into Disneyland for free? No. Can you get into Disneyland for free at like 11, 12 years old? No, you can't. Okay, so it's 2. Yes, 2-year-olds can get in. So it's including that point and smaller, like 1 and babies, they can get in for free. Okay, but no more than 2-year-olds can get in for free. It's 2 and below. And then the opposite of that is true. When you see at least or no less than, then instead of it being a less than sign, it's actually a greater than sign. So you can be at least 16 years old to drive without an adult. Okay, at least 16. So that's 16 and older, right? You see the word at least, you would think a less than sign, but it's actually greater than or equal to. You could be equal to 16, but they prefer you to be older. Little 5-year-olds can't be behind the wheel of a car, right? So they can't be over here. It has to be greater than. So when you see the word at or no, it's the opposite way you think. At most, no more than is not a greater than, but a less than or equal to. At least or no less than is not a less than, but a greater than or equal to. And then everything else is pretty straightforward. If it says is greater than, is more than, is larger than, is above, it's a greater than sign. It's just when you see those words at or no, alarm bells should go off that it's the opposite way you think. Okay. And then an equal sign is equal to just the word is, or they're the same thing. So 10 is the same as 2 times 5. Yeah, 2 times 5 is 10. 10 equals 10. So if they say same, you write an equal sign. Is means equals. That's important to note that is means equal because an equality is kind of like an equal sign, right? So if you see the difference between these, they almost look identical. 5 less than x. 5 is less than x. This one's just a subtraction sign. This one's an inequality sign. So the only thing that changed was 5 less than x. You're taking 5 away from x. But once it says 5 is less than x, it's a form of an equal sign or inequality. If it just said 5 is x, it would be 5 equals x. But it says 5 is less than x. So 5 less than sign x. Okay, and then those are the main tricky things to note about when you're asked to write out an inequality. Okay, for the last one, it basically asks you to come up with your own type of equation. And so you got to come up with a scenario. It said use, what are you solving for? And then choose a variable to represent it. Are you talking about the number of rides, number of feet, like anything you want? And then determine the result of the situation that you came up with. The total cost, the total height, the difference in weight, anything you want. So the situations that I came up with were, they only gave me 2 spots. So this one was probably going to be a multiplication. Whenever you see the word per, each, or every, that's your indication that you're going to multiply your number with your variable. So it says $7 per movie ticket. I'd love to go to that movie theater. So you would do 7 times however many tickets you buy equals the total cost you're going to pay. So if they said the cost was $28 and you had to solve for how many tickets you got, well, $7 per ticket, so times each ticket you buy, equals the total cost. How would you solve for T? Divide by 7, and this becomes T by itself, and 28 divided by 7 is 4. So you bought 4 tickets if you spent $28. Okay, for this one, I was able to add something. So since they gave me the idea of height, I was like, all right, I started at 4 feet. Then I grew some number of feet, and I ended at 4.5. So doesn't it make sense that your starting plus however many grew equals your ending height? So then I plugged in, okay, I started at 4. They didn't tell me how many feet I grew, but they told me that I ended at 4.5. So then how much did you grow? Well, these are being added. So the opposite of adding is to subtract. Subtract 4 from 4.5, and you just get a half. So we grew half of a foot. Writing out what it is you're talking about before you write out your equation is sometimes helpful. All right, my little mathematicians, good job. You've mastered yet another standard.